This video covers Pre-Calc Notes 9.3. It's part 1 of the video. We're going to cover the topic today being geometric sequences. You'll notice in our last video we talked about arithmetic sounding a lot like arithmetic, where we would have to add a common difference to get to the next term. For geometric, we're going to be multiplying by the same number to get to the next term in our sequence. So we're going to be using multiplication. So if I give you a sequence 2, 6, 18, 54, to get from 2 to 6, what do you have to multiply by? You times by 3. To get from 6 to 18, again you multiply by 3, and to get from 18 to 54, you multiply by 3. So instead of calling this the common difference, like we did when it was arithmetic, what we call this now instead of the difference is the common ratio. And we're going to denote this with an R in our formula. So let's talk a little bit about how to get the formula before I show you down here what the actual formula is. So when we think about our first term of the sequence, first term of our sequence was 2. Okay? Then to get our second term of the sequence, what we did is we took our first term and we times it by 3. We got 6. To get our third term of the sequence, you take the first term, you times it by 3. In other words, you took the second term, and then you times that by 3. And to get the fourth term, you take the first term, you times it by the second term, or you times it by 3 for the second term, you times that by 3 for the third terms, and then you times that by 3 for the fourth term. And you could keep doing this for all terms of the sequence. So how are we getting this? Well, what we're doing then is we're taking our first term of the sequence is just our first term of the sequence. Our second term of the sequence was the first term times the common ratio 1 time. The third term was the first term of the sequence times 2 of the common ratios. So it would be the common ratio squared, not 2 times the common ratio. And then finally the fourth one was a sub 1 times 3 of these common ratios, so it would be the common ratio raised to the third power. So notice here that if n is equal to 2, we're using 1 common ratio. Notice here, when n was equal to 4, we use 3 common ratios. So we're using 1 less common ratio than whatever the n value is. So that's how we can get our formula. We can say that the nth term of the sequence of a geometric sequence would be the first term times r raised to 1 less than whatever the term of the sequence is. And this is going to be the formula that we're going to use then to help us find the nth term of the geometric sequence. So understand now that we're using multiplication. If we notice that we can multiply each of our previous terms by the same number to get the next term in our sequence, it's going to be geometric. If we notice we have to add, so like here I could say, oh, I add 4. But if I add 4 to 6, I don't get to be 18. So I know that this is not arithmetic. I recognize that I have to times them all by the same thing to get to the next term. So that's why it's geometric. So now we need to pay close attention to whether we have an arithmetic sequence or a geometric sequence. So if we continue with the sequence that we were just dealing with, we recognize that our common ratio was 3. We were timesing by 3 to get to the next term. So our common ratio was 3, and if I want you to write the nth term, if I want you to find the nth term or write the formula for that, then you need to know the first term. So the two things we need to know, again looking at the formula, is we need to know what the first term is, and we need to know what the common ratio is. So in our problem, our first term was 2. So plugging into here, take the first term 2, times that by 3 raised to the n minus 1. And that would be the formula for the nth term of the sequence. Now you don't want to multiply these together and say that it's 6, because you have to do exponents first and then multiply that answer by 2. So you want to leave your answer like this. There is no more simplifying that we can do with a problem like this. Okay, so let's apply that. If I want you to find the 15th term of the sequence, if you know that the first term is 20 and the common ratio is 1.05. Remember, those are the two things that you need. Let's plug it into the formula. A sub n would be equal to 20 times 1.05 raised to the n minus 1. So that's my generic sequence. Specifically for this problem, I want you to find the 15th term. So the 15th term would be equal to 20 times 1.05 raised to the 15 minus 1 power, which is 14. So I'm going to do 20 times 1.05 raised to the 14th power. And rounding that, I would come up with an answer of 39.60 as the 15th term. Okay, so now I have a sequence that keeps going on, and I'm asked to come up with what the 8th term of the sequence is. So since I have the first 4, what I could do is figure out what do you have to multiply this by to get to the next term, and then I could just keep going. I could find the 5th term that way, the 6th term, the 7th term, and the 8th term. So I can, because I only have to go to 8, I could take that shortcut and just keep multiplying by 1/3, negative, or whatever my, I said 1/3. I don't necessarily know yet what my difference, or my common ratio is. So let's figure that out. What do you have to multiply negative 1/3 by to get to 1/9? Well, I know it's negative to positive, so it's got to be negative. And then the problem has to be negative 1/3. Because I know that negative 1/3 times negative 1/3 is positive 1/9. Let's just check to see if that works for here. If I multiply by negative 1/3, is negative 1 is positive 1/9 times negative 1/3, that's negative 1 over 27. That's what my next term of the sequence is. So I figured out that my ratio so I moved this up to give me a little bit more room here. So we had discussed that our common ratio was negative 1/3, and our starting term is also negative 1/3. So remember, the generic form of the formula is the first term times the common ratio raised to the n minus 1. And in our problem, they're both negative 1/3. And if I ask you to find the 8th term of the sequence, that means it would be 8 raised to the first. And so when I do this, this is going to be the 8th term would be negative 1/3 times negative 1/3 raised to the 7th power. So let me just do that portion first. If I deal with just this in the calculator, it'd be a negative 1 over 1,287. And then I times that by negative 1/3. I get positive 1 over 6,1. If your calculator is struggling to turn it into a fraction, don't plug it in as a fraction. Do 3 to the 7th power to get this. Then just do 3 times 2,187 to get this, and recognize that in the numerator you would just have a 1. So again, if you're struggling with the idea of the fractions here, don't type it all in as fractions. The other thing is, you can type this all into your calculator at once, but you're going to have to insert a lot of parentheses. You'd have to insert parentheses here, here, and here. So I don't recommend that you try to type it in all at once. Take the time to do it in multiple steps. Okay, so now I know the 2nd term of my sequence is 3, the 5th term of my sequence is 3 over 64, and I want to know the formula for the nth term of the geometric sequence. So I want to know what this would be. So the things that I need to know to be able to plug into this formula are what is the first term and what is the common ratio. I don't have enough information right here to be able to go backwards to figure out what that first term is. So what I need to do is plug in what I know. The 2nd term of the sequence. So if I'm plugging in here, my 2nd term of the sequence is 3. So that would be the first term times the common ratio raised to the 2 minus 1, because it's the 2nd term of the sequence. The 5th term of the sequence, so if this is the 2nd term, then the 5th term of the sequence would be found by taking the 5th term of the sequence, setting it equal to the first term times the common ratio raised to the 5 minus 1. So over here, I get the first term basically times r, because that would be the first power. Over here, I get the first term times r to the fourth power. So what I'm going to do here is I'm going to take the time to solve this problem for a sub 1. So I would divide by r. Now the reason I did that is so I can now replace a sub 1 in this problem with a 3 over r, and I can solve it. So this would be 3 over r, and I'm going to times that by r to the fourth. So when I do that, I get 3 over 64 equals 3r to the fourth over r. Well, I can reduce this to make this just become 3r to the third, because these would reduce down to r cubed. And now to solve this, I would divide by 3, and it gives me 1 over 64 equals r to the third power. Get rid of the third power by taking the third root. Now I can take the third root of this, because both of these are perfect third roots. The third root of 1 is 1, and the third root of 64 is 4. Again, I could use my calculator to find that also if I wanted, but I know that 1 and 64 are both perfect third roots. So I've got the r value. I can find now the first term of the sequence by going back and plugging into this equation here that I wrote in red, plugging in an r equals 1/4. So if I do that, I'll do that over here, into this equation, plugging in an r of 1/4. So to get rid of the 1/4, I'll times by 4, and I should get the first term of my sequence then to be equal to 12. That's crucial for me to be able to now do what the problem says, which is write the formula for the nth term of the sequence. So the last thing I'm going to do is I'm going to take this formula and I'm going to plug into it the a sub 1 and the r. I'm going to do that way down here. So the nth term of the sequence would be 12 times 1/4 raised to the n minus 1. Let's just take the time to check this to make sure that I got this sequence right. Here's what I know. I know the second term of my sequence is 3. So if I plug a 2 into here, do I get 3? Let's check that. 12 times 1/4 raised to the 2 minus 1. 1/4 of 12 is 3. So I do get 3. And that's what I wanted to do. I could check it with this one if I wanted it as well. I could plug a 5 in for here and do 1/4 raised to the fourth power, times that by 12, and I would get 3 over 64. So again, the important thing to remember when you're doing a problem like this is you need to know the first term and the last term, or excuse me, the first term and the ratio, the common ratio. And from what we were given here, we don't have enough information right away to be able to find that unless we write two equations. So what I did is I plugged this one in here, and I plugged this one in here, and then I used substitution to help me find one of the variables, in this case to find what the r value was by substituting out for the a sub 1. So you have to remember the rules for working with two variable equations. You either use elimination or substitution. I thought substitution would be a lot easier for this one because of all the multiplication that's involved.